We're going to take a look at the law of cosines. And the law of cosines is going to be a generalization of the Pythagorean theorem. So let's say we have a triangle. This is not going to be a right angle triangle, because if it was, then life would be made really easy for us. So we have this triangle over here, right? This is an ugly one. I think I can draw a bit better. Where's the line tool here? Let's get a fucking line tool out. Line tool. Okay, here we go. Let's do this. Okay, that's really fucking ugly. Oh my god. Okay. Why is the width so freaking big? Okay, there we go. That's what she said. Okay, let's get started. Boom. There we go. Now I look like a professional. Holy shit, I look legit. Okay, so we have this triangle over here, and we have a side that is A, and I can't write. What the hell's going on? Okay, A, C, and B. Okay, we have those sides of the triangle, and we have the angle over here. This angle is going to be theta, and we want to be able to just figure out properties, to be able to figure out the sides, and to be able to figure out the angles here. So one thing that we can note is that this is actually two right angle triangles, right? If we go ahead and put this like this, and put this like this, we have two right angle triangles. This here will be a new length here. This will be the height. And we are going to go ahead and write some, we want to fill in the blanks here for the spaces that we're missing. So we have B down here, right? This whole thing is going to be B. So I'll go ahead and lower this, because we are going to write the individual lengths of these two portions over here. What do we know about this one over here, right? Well, we know that this is going to be the adjacent side to the angle. And if we have the hypotenuse, which is going to be A, then essentially we can just go ahead and write here, this is going to be A cosine of the angle theta. So this is going to be from here to here. So we have that side over there. And now we can go ahead and draw the one over here. Now this one, we can simply know that it's going to be, we don't have an angle here. We don't want to get involved with these other angles right now. So what we can do is, we know that this whole length is B. So this whole length here is B. So we can just simply subtract B, or we can subtract, the A cosine of the angle theta from B. And that will be this side over here. So we're seeing how things are starting to form together. And now we essentially have two right angle triangles. And we're going to use that height h, right? Those height h is going to be the common term that they're going to have together. And that's how we're going to go ahead and we are going to assemble the big formula that we're going to have. So if we want, we can go ahead and write this over here. We can write that this over here, we know that, the hypotenuse squared is equal to the height. Well, in this case, it'll be this one squared. H squared plus what we have down here, which is going to be plus B multiplied by A cosine there squared. So we have that over there. And we know that for this other one here, which will be A squared, it's going to be equal to height squared plus what we have down here, which is simply going to be A cosine of theta squared. Now what we'll do is we will rearrange these so that we have the height as the one that we can eventually cancel out. So what we can do is, well, if we want to make these equal to each other, I can just save some time. We're essentially going to be, I'll go the long way just to make sure no one's getting confused. So we're going to isolate the height squared on each side. So in this case, we'll have B subtracted by A cosine of theta squared minus C squared. And this one here will be A cosine of theta squared subtracted by A squared. We're going to make these equal to each other. So we're going to go ahead and make these equal. We will do, I'll just go ahead and write here, B subtracted by A cosine of theta squared minus C squared is equal to A cosine squared minus A squared. So we can go ahead and we can break these out. Over here, we're going to simplify this one. So this is going to be B squared. This is going to be 2AB cosine. And then we're going to have, so plus A squared cosine squared. There. And then on this side, forgot the C. Subtracted by C squared. On this side, we'll have A squared cosine squared minus a squared. Okay, so now we want to simplify a few things over here. So what we'll do is we're going to bring c squared to the other side over here, which we're going to want to isolate that c squared, which is the standard one that we're going to see pretty often. So we'll bring that to the other side. We're going to bring the a squared to the other side. We're going to leave the b squared here. We're going to notice that these two terms are going to cancel out with each other, so we won't have to deal with those, and we will have subtracted our a, b cosine of theta over here, and that is essentially the law of cosines. This is the formula we're going to see all the time. So that's how we arrive at it. That's how we got from the start to the end. So we have this, and this is the formula that, okay, I'm really not good with the straight lines here. There we go. And that's the formula we see all the time, right? So when you're dealing with a triangle that does not have a right angle, this is the formula that you can use. We are essentially splitting that triangle up into two right angle triangles. And then just by using this process that we have over here, we will arrive at the end. So if you have any questions, leave these below, and we'll be looking at some more things involving angles in the next few videos.